Hi, my name is Juan Carlos Fuertes Sotoya. I am a student in the Catholic University. I am studying the career of Electronic Engineering in Control and Automation. This project, as a title, lists tips and tricks on how to verify control loop stability with Rohde Schwarz oscilloscopes. Definition: to ensure to the stability of voltage regulators and switch mode power supplies, it is necessary to measure and characterize the behavior of the control loop. A well-compensated voltage controller enables stable output voltage to be achieved and reduce the influence of load change and variation in supply voltage. The quality of this control circuit determines the stability and dynamic response of the entire DC-DC converter. Road Hansher solutions. Quality is easily analyzed. The low frequency response on the oscilloscope with the RIS RTX-K36 frequency response analysis options characterize the frequency response of various electronic devices, including passive filter and amplifier circuits. Measure the control loop response and power supply rejection radio or switching power supplies. The RISRTX XK36 frequency response analysis option uses the waveform generated built in the oscilloscope to generate simulate signals in a frequency range of the 10 Hz to 25 MHz. When measuring the radio between the input and output signal of the examining object at each of the text frequency, the oscilloscope probes on the gain logarithmically and the phase linearly. Frequency response analysis option allows you the quickly determine the gain and phase merging in switching power supplies on linear regulators. These measurements help determine the stability of the control loop. Option displays the response of the system. The change is in operating conditions, age, supply voltage, or root current. In this video, we will see some of the characteristics of the Rohde and Schwarz solution oscilloscopes.
R&S RTC 1000 series oscilloscopes provide high sensitivity, multifunctionality, and a great price. Multifunctionality offers time domain, logic, protocol, frequency analysis, pattern generator, function generator, digital voltmeter, and a component tester, all in a single instrument. It is not only acoustically silent, but it also has excellent electrical noise performance. And the best part? All is upgradable on your desk, so the instrument grows with your needs. R&S RTC 1000 series oscilloscopes boot in under 10 seconds, faster than other scopes in its class. R&S RTC 1000 series oscilloscopes offer protocol triggering and decode options. Tired of manually decoding waveforms when stopped? Even worse, it's impossible when the scope is running. Decode options understand each serial bus, determine ones and zeros, and decode automatically. Need to find a specific packet in the data stream? Simply set the protocol-aware trigger for a specific field or value within a field. Finally, a graphical and tabular view summarizes your results. R&S RTC 1000 series oscilloscopes include frequency analysis as a standard feature. Do you want to ensure that unwanted frequencies aren't coupled into your system? Or do you want to look at frequency components of your signal? Just press the dedicated FFT button to see the fundamental frequency in multiple harmonics. For optimal visibility, both time and frequency information are shown in separate windows. And finally, for faster analysis, cursors automatically identify peaks. RNS RTC 1000 series oscilloscopes include a unique component tester as a standard feature. Do you need to check if a component, like the Zener diode, is working? The built-in component tester summarizes thousands of values in one telling diagram. RNS RTC 1000 series oscilloscopes feature an 8-channel integrated logic analyzer option. Use the digital channels to see timing relationships, group multiple signals into a bus and see bus values, or view bus activity in a table complete with time tags. RNS RTC 1000 series oscilloscopes feature a standard XY mode. Plotting two signals against each other allows you to view the relationship between them, in this example a phase shift. In addition, small preview windows let you easily control the settings of your waveforms. RNS RTC 1000 series oscilloscopes feature an integrated function and pattern generator option. Use the generator as a source for a variety of wave shapes. A preview shows key parameters. Easily adjust settings like amplitude and frequency. Use the 4-bit pattern generator to create stimulus for your device under test. Or output packets for industry standard serial buses.
In this video, we will see a deep definition about Rohde and Schwarz solution oscilloscopes.
Imagine that you were given 8 instruments in a compact, lightweight package. Imagine that it had the same performance as lab instruments, but was still portable and rugged for use in the field. You've just imagined our new handheld digital oscilloscope, the Rohde Schwarz Scope Rider. Give us 2 minutes and you will never look back. The Rohde Schwarz Scope Rider delivers the capabilities of a lab oscilloscope in a handheld package. Custom-designed integrated circuits and the dual-core system on a chip-based processing architecture yield top performance and speed. Troubleshooting industrial equipment and electrical installations in the field, or debugging power circuits with dangerous voltages in the lab, both require independent isolated channels with highest safety ratings. The isolated Ethernet and USB interfaces ensure that you can safely connect to the instrument when you measure. The large capacitive touch panel provides a crystal clear signal display and lets you intuitively control the device. Large buttons make it easy to operate the instrument, even when wearing gloves. And the multifunction wheel allows settings to be quickly adjusted. The Rohde Schwarz Scope Rider makes your daily measurement work easier. Collect all your measurement data at the push of a single button and download it later to your PC via wireless LAN, Ethernet, or the USB interface. And finally, the 8 instruments in one make the Rohde Schwarz Scope Rider the perfect multi-purpose tool. Experience unsurpassed versatility in your hand, in the lab, or in the field. Any place you measure, the Rohde Schwarz Scope Rider is the perfect companion. And when extra safety is needed, the Rohde Schwarz Scope Rider can be remotely controlled via wireless LAN, separating the measurement location from the place where the user controls the instrument. The Rohde Schwarz Scope Rider, more than a handheld oscilloscope.
Measurement setup. The power supply control loops compare the reference voltage on the feedback voltage and create negative feedback to ensure a stable output voltage. For control loop response test is necessary to insert an error signal across a frequency band into the control loop feedback path. To insert an error signal, it is necessary to incorporate a small resistor in the feedback loop. The 5 ohms insertion resistance shown in the figure is negligible compared to the certain impedance of R1 and R2. Some users choose to permanently plan on this low value insertion resistor for testing purposes, and insert transformers such as XP-toasted G21008 is loaded the AC distortion signal and eliminates any DC bias. Device configuration. After connecting the oscilloscope to the circuit under test, start the application. Set the start and the frequency between 10 Hz and 25 MHz and determine the output level of the generator. Adjust the point per declinate to improve on the modify the definition of the acquisitions. The oscilloscope is support of the 500 points per decade. Profile the amplitude of the generator output to eliminate noise from the circuit under test. And press the start key to start measurement. Measurement results are deployed as gain, phase over frequency. Set the market at the point of interest. In this video we will see the configuration of these devices.
Okay, let's take a look at the FFT capability on the HMO 1002 and 1202 series of scopes. What I have right now is I just have a square wave that I'm outputting on the pattern generator. It's a square wave at 5 megahertz, so we'll have some good harmonics that we can take a look at. One of the first things you'll notice is that there's a dedicated FFT button on the scope, and we'll go ahead and turn on the FFT capability. And the next couple things that you'll notice are the fact that we split the display, so you can still see the actual waveform itself up above, and then we have the FFT down below. And a couple things to notice. One, you can control the span of the signal that you're looking at by using the horizontal division control. You can also use a position control to change where the signal is located on the screen and essentially set your center frequency. And so we'll set our center frequency at 25 megahertz. We've got a span of 50 megahertz. And now you can see that as we come through, our first harmonic is at 5 megahertz. Our third harmonic is here at 15 megahertz. Our fifth harmonic is at 25 megahertz, right on the center frequency piece itself. A couple other things that are really kind of unique in this class of scope. You can adjust your Y scaling. You can change your windowing capability. You can also adjust the mode that we're operating in. So you can do an envelope mode, and you can also do an average mode that allows you to really pull small signals out of the noise, for lack of a better term, and be able to see tiny spurs that might be popping up. You can adjust the number of averages. You can also adjust the number of points, and so the number of points can go all the way up to 130,000 roughly points for the FFT, and that's going to give you additional resolution on the FFT itself. And one very cool capability that it has is the ability to come in and turn on cursors. And the cursors will go through and actually find the peaks for you. So we can say, let's find the previous peak. We'll go to the very first one. As you can see, it's at 5 megahertz. If we go to the next peak, so this is interesting, you can see that we can barely pull out the second harmonic at 10 megahertz. And then we can go ahead and step to the next peak after that. This one's third harmonic at 15 megahertz, fourth harmonic at 20, fifth harmonic at roughly 25 megahertz. So very powerful capability to make it very easy to be able to see information on the display and not have to guess and have the scope actually measure it for you.
Pros and cons. Pros. The decline measure the big voltage of a signal. The decline measure the period of a signal indirectly determine The frequency of a signal measures the phase difference between two signals, determines which part of the signal is DC and which part AC. Cons: the measurement of voltage peak values, peak to peak values are not exact as DC measurement can have a minimal reading error, either to the state of the instrument or the environment where the measurements are made. Application in electronics. An oscilloscope is an electronic display instrument for the graphical representation of electrical signals that can vary over time. It is widely used in signal electronics, often in conjunction with spectrum analyzers. It presents the values of the electrical signal in the form of coordinates on a screen where normally the x-axis represents time and the y-axis represents voltage. The image that optimally is called on oscillogram. They usually include another input, called the tracer axis of one cylinder, that controls the brightness of the beam, allowing some signals of the tracer to be high or turned up. Oscilloscopes classified according to their internal functionality. They can be both analog and digital, with the results shown being indicated in either case. Use applied in Ecuador. Oscilloscopes are used for multiple functions. If we equip this instrument with an element capable of converting a physical magnitude into an electrical signal, a transducer, it will be able to measure from what we have seen from a revised device to a doctor when analyzing the heart rate or blood pressure. Conclusion: oscilloscopes are some of the most versatile instruments out there and are used by TV repair technology to doctors. An oscilloscope can measure a large number of phenomena, provide with the appropriate transducer and element that convert a physical magnitude and an electrical signal. It will be able to guide as the value of a pressure, hear rate, sound power, level of vibration in a car. The word oscilloscope describes an instrument that allows to observe oscillations. By oscillation, we mean any vibration or change, a physical phenomenon that can be converted an electrical signal proportional to it. The oscilloscope grabs the amplitude change of a signal with respect to time. Therefore, it allows to determine amplitude, period, DC level, among other characteristics. Thank you.